This part hole idea is pretty interesting one, and a great example I find is, and I will tell where this is coming from, is just consider yourself walking onto a beach and trying to sort the grains into piles, right? So you would look into color, translucency, size, how smooth it is, and so on and so forth. Let's say you have 9 different clusters, but then you pick one, you find another piece grain, which is totally different than the other ones, right? So your cluster of 9 is not working anymore. If you're looking into machine learning, this would make sense too. Which means that our way of sorting doesn't work all the time for design or for our ideation. We have to, be open-minded and leave our rules when they don't really work. And this is coming from the Zen and the Art of Motorcycle Maintenance. So, Pirsig's example of, he calls this analytic knife. We split the world into pieces, but those pieces don't really exist, right? So those clusters or groupings don't really exist. We just try to, again, make it into a data that we can kind of make sense of. And your knife would be different than mine, right? So I would cluster them in a different way. You would do it in a different way. And also, this is also not, it's domain specific, right? So if we talk about pistons, for instance, what a piston is, just moving from motorcycles to engines, we can talk about the function, right? So that would bring in a different type of visualization of the pistons, whereas a patent drawing would concentrate on, what the part number is and where it is. An airbrush drawing would focus on more on the aesthetics, and the final render that you see at the right bottom is just making the piston an artwork, right? So the same thing when I tell, hey, pistons, or when I say building, it means totally different things in different domains and different times. So we have to be conscious of that too. And in this case, this is Judd Turner, J-U-D. He's a pretty interesting artist. He kind of mixes these engine parts and pistons and bones to make these, artwork. So here's an engine for you, right? So or piston for you, totally different description. And I think that's very powerful for design, right? So the shoes, as we know them, they're like this, one of these things, right? So it has the bottom part, which is the midsole. It has the top part, which is the upper, and you have laces maybe or not, and so on and so forth. To me, among these, I think this is the closest one because it gives the feeling of this like mushiness of the shoe, right? So it's not something this like, if it is like a block, it's going to hurt you anyway. So I wouldn't take that description. So what we are looking into is, okay, how can we rewrite or change the part descriptions for performance, right? So what you're seeing here is this guy is an older design. And it has, multiple materials and geometries nested into each other to achieve some sort of performance, which is, let's say, the support under the heel, but also like some stability on the medial side of the shoe. But here, what you're seeing is, it's totally replaced with one single unibody structure, right? Which is this thing. So what you're doing is you're taking the function and you're using one single material. By using lattices, you can create this sort of performance without using multiple materials or assembly within the heel. But this is not totally erasing the assembly of the shoe, right? So that's another level, let's say. And the other one is, okay, that was a heel component. This is a forefoot component. And I happened to work on this. This was a pretty exciting experience for me, which is again, the same material, different lattice, and in this case, you're looking for propulsion or like bounciness as opposed to stability and cushioning and so on. So it's a different understanding. And it's kind of fascinating to be able to do this with the same material, because conventionally you have to change the foam to, A to B to C to achieve different performances.